So, welcome to this another course, that power system engineering. Previous semester or previous this thing, another course was there, power system analysis. There we have seen something, and many of you have registered or given exam and taken that course. So, this power system engineering, I thought there are something interesting topics are there. So, in this course, first thing is that this course is suitable for the third year electrical engineering students. This is as well at the same time the final year students also can take this course. In addition to that, those who have passed out, they also can take this. So, in this course actually I forgot to bring that one, that before telling something some content of this course. So, what we will do, I am telling from my mouth, you should this thing. One thing is that you will read the book of that Turan-Goinen, that power transmission system, I think title, just see that Turan-Goinen book. Then I have also authored one book, 1 or 2 chapters from that book you will find electrical power system. In addition to that, you see the Elgard book, then your if I recall correctly the name, that another author is there, B.R. Gupta, and at the your apart from B.R. Gupta, that one more book is there. I mean other book is there that your I cannot recall that name of that book, but in some lecture I will show you that book, right. So, Hussain, I think A. Hussain, I recall now, right. So, these are 4-5 books, you please go through it before telling. Now, I will come to the course content. So, in this power system engineering, that first thing is that following topics I have selected before giving few second description of that insulators, then cables, then your the transient over voltages and insulation coordination. Then we will go for corona loss, sag and tension, then voltage, your load flow of radial distribution network and voltage stability, then approximate method that is applied to electric power distribution system, then your application of capacitors to the distribution systems, then load frequency control you will see in detail and you will find very interesting of all this, and addition to that unit commitment is also there. So, this way I have to condense it in 30 hours, and first thing we will start with insulators. So, various different type of insulators, and whatever mathematical derivations are there for each chapter, whatever theories will be derived, then all the, and it will be supported by a very good number of examples, good examples. So, one insulators will done, then cables. So, in the cables, different type of cables we will see, and all these mathematical derivations will be made for the cables, underground cables, right. And you will find these things, insulator and cables, initially little bit of theories, after that you will find things are quite interesting, right. After this I will go to your transient over voltages and insulation coordination. That transient over voltages, you will find that how that current waves and voltage waves and your what you call all sort of surges, and lightning if it happens on the sealed wire or any tower, how travelling waves behaves, and all sort of things we will see. In addition to that, insulation coordination. After this we will go for corona loss. It happens in high tension line. So, corona loss is a very interesting thing, and formulas you will find mostly your empirical formulas, but this corona is very interesting. We will be try to explain in detail for all this topic. After that, sag and tension of the transmission line, right. Detail will be covered for sag and tension of the transmission line, including ice coating and other thing, and all sort of combinations. I hope you will find this interesting. But apart from this, that what I have decided, that I thought that load flow studies you have studied in the power system analysis in previous course, I have given the Newton-Raphson method and Gauss-Seidel method. but load flow for radial distribution system, that we will follow a at least two different techniques for solving radial distribution network without Newton-Raphson or Gauss-Seidel. We will follow different thing, because why I have chosen a distribution system, because nowadays that renewable sources, that is your non-dispatchable DGs we call renewable sources or renewable power generations, and your dispatchable DGs, I mean those things are immensely connected to the your distribution side. So, distribution system is getting more and more importance, and often I got some request from somewhere, sir, in future if you take anything, so please try to cover your distribution side little bit. So, I hope you will find things are very interesting, and some flavor of voltage stability of radial distribution system will be given, and problems whether it is load flow or your voltage stability, whatever problem will be taken, it can be solved in the classroom also, in the classroom only, that way I will teach. I do not want to teach the things which cannot be solved in the class or in computer, that is a different issue, right. Only I have to see from the classroom point of view, and that application of capacitors to distribution system also will be covered, and in addition to that approximate method for distribution for calculating losses, calculating your what you call that voltage at different nodes, approximate method will use, and some flavor I will give that distributed generation they call DGs nowadays, because these things are getting so important, that concept of smart grid, microgrid, nanogrid, all sort of concepts are coming, but I do not want to teach you microgrid or smart grid, I have no intention to that at BTech level, right. But when I will teach distribution system, at that time this DG concept will be given, that lagging power factor DG, unity power factor DG and leading power factor DG, and this concept how we will consider in the your model, how we will consider in the distribution system, that I will try to cover. So, you will find this all these things are very interesting, and if you have any difficulties you can send mail to me. Whatever I received, I think several mails from all of you for the previous course, and I replied to all of them. No one can say that I have not replied, I have replied to all. Then after this load frequency control will be there. This course will find very interesting. I have no idea whether load frequency control part is there in your third year or fourth year, I have no ideas, but mostly it is in third year. So, load frequency control I will tell you everything. Okay, I mean it is load frequency control of starting from the speed governing system, then load frequency control of isolated power system, then interconnected power system, and all the derivations, and with several examples all these things will be supported, right. So, load frequency control you will find things are very, it is a control part, and you will see the steady state error of different combinations, and all the your detailed block diagram, everything representation will drive. It may take a few hours, right. I do not know how long, but I believe in the studio when I record it, it may take 5 to 6 hours or even more, right. And after this we will come to the unit commitment. I have to see that unit commitment thing can be solved in the classroom only that kind of problem, and different your what you call, as far as classroom is concerned and you can solve it, that kind of problem will be taken, because unit commitment is a very important topic for power system. With this, so this course you have altogether 10 different topics and 30 hours, that is I have thought for. If it takes little bit more than 30 hours, it does not matter, but I will try to condense it in 30 hours, and all the chapters whatever problem I will take, please try to understand, and all the things will be supported by good examples or good numericals. So, with that I will tell that like previous course, you please go through it and just see how it is, right, because whatever I mean whatever you will see, your feedback will be more important for me. If you find anything is missing or anything is there, you can send to mail, I will rectify. And when I am writing on the sheet, all these things written by me only, there is a possibility that I may make mistake in calculations, other things. So, if you find anything anywhere it is incorrect or I have done wrong calculations throughout this course, just please send me mail, so such that I can I can rectify myself. So, with this I will tell, just see this this new another one, that power system engineering, and just have a look how it is. With this I say thank you to this thing for when this course will start, and book all this thing somewhere in that your in middle, I have told you all these books, that B. R. Gupta, then H. Hossain, then Oli the Ian Elgard, Y. Elgard, then my book, and Turan Gonan. These 5 books will be more than enough for because different book have different chapters, but for distribution load flow I cannot refer you any book, but everything whatever I will because those things are not available for balanced distribution system, because I will cover only balance. Unbalance will be very difficult for the classroom purpose also, because mutual coupling has to be considered. So, that is why unbalance will not be taught, but load flows for balance actually it will not be there. But when I will teach that balance distribution, load flow, capacitor, everything, just please take it seriously that how I am making it, right, because for that I cannot refer you book, but but everything will be explained in the classroom, just follow that, right. 1 or 2 research article I can make as a reference, but I do not want that, but whatever will be done in the class, that will be more than sufficient. All these things will be derived in detail. With this, thank you very much.